Welcome to Steady Life. In today's section of mechanical properties of solids, we are going to learn something about elastic limit and Hooke's law. What is the story about? Let's start to something very simple. In the previous videos, we have learned about stress. Stress is nothing but the force acting per unit area, and every time there is some force acting on our requisite subjects, we understand that there is always some amount of strain that is observed in there. So for every stress, there is strain. But do you think any amount of stress will work? Is there no limit to what stress should be? Do you think so? No, it is nothing like that. We have a very specific limit up to which the properties of elasticity work, after which none of these properties are functional. That limit is called as elastic limit. So if ever someone asks me to write the definition to elastic limit, the only answer I have is elastic limit is nothing but the maximum stress. It is the maximum stress up to which the properties of elasticity are effective and working, after which the properties will not be as functional as before. That was our elastic limit. What happens with Hooke's law? Like, what basically is Hooke's law? Hooke's law, Robert Hooke, he proposed this law saying that somehow the stress and the strain are interconnected to each other. Somehow the stress and the strain are interconnected to each other. He found and he observed that, let me just write it down so that it becomes very easy for you people to understand. He said, within elastic limit, the stress acting on a body is directly proportional to the strain produced by the body. Stress is proportional to strain. That was the idea proposed by Robert Hooke, in which he said that if I decide to increase the strain, all I have to do is increase the stress. If I increase the stress, the strain will increase. If I decrease the stress, the strain will also decrease. That was expressed by Hooke's law. Hooke's law says that this is only possible if the object is under elastic limit. Once the elastic limit is crossed, this law no longer validates. Let me work on this law a bit more. Here I have a thing called as proportionality. If I try to remove proportionality, I will have to introduce a constant. Let me just write my constant as m. What is m? What is m? Let's see. M is called as modulus of elasticity. What is m called as, bachcha log? M is called as modulus of elasticity. It's a very prime thing that we're going to learn very soon. As of now, let's just learn what m means. Let's focus here again. Stress is equal to m times strain. So if I decide to calculate the value of m, all I have to do is divide stress by strain. From this, we understand a few things. The very first thing is the unit for m, the unit for modulus of elasticity. Since modulus of elasticity is nothing but a ratio of stresses to strain, strain has no units, no dimensions. So the units of stress will be applicable to the units of modulus of elasticity. That means the unit of modulus of elasticity is Newton per meter square in the SI system. If I decide to write this in the CJ system, this becomes Dian per centimeter square. As per dimensions are concerned, dimensions of strain is m to the power 0, l to the power 0, t to the power 0. That makes it a dimensionless quantity. Therefore, the dimension of stress is same as the dimension of modulus of elasticity. What is the dimension of stress? It's m to the power 1, l to the power minus 1, t to the power minus 2. This happens to be the dimension for stress. Okay. So now I suppose you are very much sure what elastic limit is and what Hooke's law is. So that was my session today. In our next lectures, we'll be learning a lot more. But until then, stay learning with me on Steady Life. Thank you.